Hey, so today's question is pretty simple but tricky. Can water keep dissolving things forever? Let's find out. What happens when I stir sugar into this glass of water? Let's look at this video. So here I am adding a spoonful of sugar into a glass of water. When I stir it, the sugar gets dissolved fully. Now let's add another spoon of sugar in the same solution. Do you see that? Some sugar molecules are still not dissolved, no matter how hard you stir. And no, this is not because I didn't have enough power to stir, because the water is now saturated. It can't hold any more sugar. That's what we call a saturated solution. So if we need to define it, you can say that when no more of a substance can dissolve in a fixed amount of water, we say that the solution is saturated. Let's try to understand this from a perspective of science. So here water acts as the solvent, sugar acts as the solute, and solvent and solute together create the solution. So from these terms, we can define saturated solution as a mixture where no more solute, or in our example sugar molecules, can dissolve in the solvent, which is water. Now let's think a bit deeper. Can we make the water take more sugar if we help it a little? Let's heat the solution that we prepared of sugar and see what happens. As you can see through this very pretty looking glass kettle here, the same saturated solution of sugar with some undissolved sugar is heated, and in a short while, when you try to stir the mixture after heating it, you will see that sugar molecules are disappearing again. Here I am doing this under an expert supervision. I am suggesting that you don't do this on your own at home. Do it on some expert supervision who can help you deal with the fire and gas stove. Alright? So coming to our point here is that, as you can see, sugar molecules have disappeared again. In other words, we can say that heating increases the solubility, especially when the solutes are solid. But this is not the case always. Most of the gases and some salts like sodium chloride or calcium sulfate, they barely change their solubility with the temperature. This brings us to the next idea. What if the substance doesn't dissolve at all? How does saturation come in picture for them? For that, let's try adding wheat flour in the water. As soon as you add wheat, you can see that instead of dissolving in the water, it is spread throughout the water, not getting dissolved. You can keep stirring it with all the force you got, but you will see that it is not getting dissolved at all. As you even wait for some time, allow it to settle down, you will see that most of the wheat just settles down at the base. It does not get dissolved. What happened here? It is just that wheat flour hardly dissolves. Just a tiny stress slips into the water, and that tiny bit reaches to the saturation almost instantly. In other words, dissolving capacity of water for the wheat flour is so low that it reaches the saturation for wheat flour even with that tiny amount. Now let's try the same experiment with a different item, salt, and check that do all substances saturate the same way. Let's try adding salt at this time. As you add salt in the water and stir, you will see that salt takes longer time to totally dissolve in the water. It stays in the water as suspended particles for long time. As you can see in this video, that the water has become a bit hazy for start. And when you keep spinning it, even after you may see that the water is transparent, but if you look at it closely, you will see some particles, enjoying their diving sessions in the water. So basically, salt takes longer time to dissolve and saturate the solution, which leads us to the fact that different substances dissolve in different amounts and in different time. So what did we learn today? We learned that a saturated solution holds up as much solute as it can, and when I say it, I mean the given amount of solvent can. We also learned that heating usually helps dissolve more, especially for solids. But remember, gases behave quite oppositely and some salts barely change. We also learned that some substances like wheat flour, or you can even try chalk powder, they hardly dissolve. Only a trace amount of it does, and that trace reaches the solution almost instantly. The rest just settles down in the water or whatever solvent that you are taking. We also learned that different solutes saturate at different points. Now it's the challenge time. Can you think of a way we can use this saturation to separate things? You might have seen it somewhere around you. Comment your idea below or your observations below and keep those science brains buzzing. Thank you.